Eduardo has one bag with 6 blueberry and 4 raspberry gummy worms. He has another bag with 4 red and 8 black licorice sticks. If Eduardo takes 1 gummy worm and 1 licorice out of each bag, what is the probability he will get a raspberry gummy worm and a red licorice? So I need to find the individual probabilities of a raspberry gummy worm and a red licorice. So raspberry, there's 4 out of 10. So that probability is 2/5. So that's the probability of pulling a raspberry gummy worm. And then a red licorice. So red and black adds up to 12 total. And there are 4 red. So if we go ahead and reduce that fraction, it's 1/3. So to find a combined probability, we're just going to multiply these two. 2/5 times 1/3. So the probability is 2 out of 15. Okay. Multiple choice test consists of questions with 4 possible answers. What is the probability of getting a question right by simply guessing? Okay, well there's 4 options, so it's 1 out of 4. What's the probability of getting 2 questions right in a row simply by guessing? 1 times 4, 1 times 4. So that's going to give me 1/16. What is the probability of getting 5 questions right in a row simply by guessing? Okay, well that's 1/4 times itself 5 times. Okay, so this is 1 times 1 times 1 times 1 times 1, 4 times 4 times 4 times 4 times 4. That's going to be 1,024. That is not very good odds of you guessing 5 questions in a row correctly. Okay, in a card game, the player picks a card from each of the piles without looking at the cards and adds the 3 numbers together. Which sum is most likely and how do you know? Okay, which sum that is possible is least likely and why? So I think I need a little bit bigger piece of paper for this because I'm going to have to list out all of the potential outcomes. All right, so in pile 1, we've got 1, 2. We're going to need a big piece of paper here to draw a tree diagram. So pile 1, we could pick a 1, a 2, or a 3. Okay. In pile 2, we can pick a 4, 5, or 6. So 4, 5, or 6. Okay. The next pile, we can pick a 7, 8, or 9. So there's going to be branches off of these. 7, 8, 9. 7, 8, 9. 7, 8, 9. I'm not going to write all the 7, 8, 9s. I'm just going to draw a branch that starts with 7 because you're going to see a pattern in a second. Okay, we need to tally how many times a sum appears. So this is going to be 4, 5, and 7 is 12. So 12 occurred once. And now it's just 1 more. So we're going to have 13, 14. 13, 14. Okay, they each happened once. Now, here I'm going to start with 1 and 5 is 6, plus 7 is 13. Then I have 14. Then I'll have 15. Okay, took care of that one, right? We're going to check these off. Now, this one has 7 and 7 is 14, 15, 16. Check that one off. All right, this one is 1 more than the one above, right? 7 and 4 is going to give me 11, plus 12 is 13. So what we can do, this one's going to go 13, 14, 15, 13, 14, 15. This is going to be 2 and 5, and 7 is 14. So we have 14, 15, 16. Okay, I just did that one and that one. So this one's going to be 13, 14, 15. So 15, 16, 17. Okay. Now, so we took care of that branch. Now let's take a look at this branch. I have 3, 4, and 7. So that's 14, 15, 16. Now here I've got 15, 16, 17. 15, 16, 17. Okay, we took care of that one and that one. And we got one more. So I've got 16, 17, 18. 16, 17, 18. Okay, so if we take a look at this, we should make sure that it adds up to, we had 3 options, 3 options, 3 options. That's 27. So if we add all these up, it should be 27. So we have 1, 3, 6, 7, 6, 3, 1. Okay, if I add those up, I do indeed get 27. So it looks like 15 is most likely with 7 out of 27, and 12 and 18 are least likely with 1 out of 27. And that would be your explanation. The most likely is the number 15, 7 out of 27 occurrences. The least likely options are 12 and 18. Both have just 1 out of 27 occurrences.